So I guess I'll start off by saying this is a conversation more than as much as it is a presentation. And why I say that is because this data mesh concept is new. And when I mean it's new, it's like the book on it is literally being written as we speak. So the book has yet to be written. The creator of data mesh is writing it now. And so this is really, Kevin mentioned that I kind of observe trends in the industry and help make sure that PM Square understands those trends and that we can explain them to our customers. And that's what today's session is all about. And I know Mike and I are really excited to present it because when I first encountered the data mesh idea, and I just got really geeked about it because it's honestly a new way of thinking about how to do analytics within an organization. It's not a new piece of technology. It's not a new software that you're going to run out and buy. It's not a technology-centered approach. It's a total rethink of who's in charge of what when it comes to maintaining data within a company. And it's the first time I've seen something like that in a long while. So I immediately got excited. I started talking to Mike about it. I think he got excited too. And really, we wanted to focus today's presentation on the idea of the data mess that exists today and kind of what it is, how we got there, and then address what is data mesh and how can it help address it. Now, I'll be upfront and say there's probably one expert on data mesh in the world right now. That's Zhamak Dehghani, the woman at ThoughtWorks who created the concept and who is writing the book I mentioned before. And that's why I say it's a dialogue that we're having. So we're sharing with you what we've learned and giving you our thoughts about how to deploy it. But we'd also like to hear back from you, what you think of these ideas, what your experience with these concepts are, and how you might be able to apply them internally. And with that, I think we'll get started. Anything you'd like to add to that, Mike?
No, that's a great introduction. I'm glad you established the fact that neither of us claim to be data mesh experts. I wanted to make that clear myself, but it is very exciting. I like your term geeked about it as well. And I look forward to, even after this presentation, continuing that conversation as well with the larger community and those who attended this session.
All right, so I'll kind of set the stage to talk about the data mess that we have today and why things aren't totally working. They're working okay, but they're not totally working. So to kind of set the stage for how we get to a concept like data mesh, we'll take a little journey down history lane and talk about some of the approaches we historically use, we still use today, even some of the emerging approaches that that are big buzzwords in the industry today, like Lakehouse, and how the data mesh concept reinforces, builds on, but also significantly differs from these. So the first thing to talk about is going to be kind of the data warehouse. So this is something we all know. This was really emerged in the 80s and 90s based on research by Bill Inman that was done in the 70s. So this is not a new concept. If you've been working in BI and analytics for any length of time, you've undoubtedly worked with enterprise data warehouse systems. It's kind of the bedrock of BI. And so what are these systems? What are they good for, and what are their shortcomings? Well, they're built on RDBMS systems. So a lot of times, most of my customers, I'd say 80%, have a data warehouse in SQL Server. A lot of them have it in Oracle, maybe some other RDBMS. And the idea behind it is we're going to take operational data that's in third normal form and transform it into a highly structured analytics ready form. A lot of times it's facts and dimensions is the most common way to refer to this, but that's a key concept. The data gets structured into the data warehouse. We have to think of the structure up front. We call this schema on write. I'm sure you're familiar with the term. And the structure is theoretically supposed to be easy to understand, right? Like I'm sure we've all read this, right? The data warehouse toolkit, or at least we've all pretended that we've read it. And that makes it seem like, dimensions and facts, they reflect the way your business really looks, and they're easy to understand, and your end users should be able to do self-service off of it. And sometimes that happens, but oftentimes end users do have a hard time understanding a data warehouse structure, even if to a data engineer, it's really easy. The data warehouse is, I think of as the analytics system of record, okay? It's not the true system of record, which is obviously the operational system, but the analytics system of record. Oftentimes there are metrics that exist in the analytics, in the data warehouse, that don't exist anywhere else. And so it can serve as that, or you might say single version of truth. These are great at answering known questions. That's what that structuring up front is you figure out what questions you want to ask, and then the structure exists to support the answering of those questions. It works very well for that. Now, the downside to this is it's complicated. The ETL processes that you put into it are complicated. Once it's built, because of that rigid structure, it's just devilishly hard to make changes. And that's something that we've all experienced building a data warehouse and how hard it can be to make those changes. You have to capture the requirements up front, or else what you do will be viewed potentially as a failure. Because it's so costly to restructure the data once it's put into this data warehouse structure. The big thing I think about data warehouses is that they're extremely useful. They're a great bedrock for traditional business intelligence. But the downside to a data warehouse is that it turns an aha moment that happens when you deliver data to an end user from a triumph into a failure. Because that aha moment, when you deliver a data warehouse to an end user and then they say, they're really happy for a week. And then the next week they start saying, you know what, I realized does it have this data? I really need this other piece of data. And it doesn't. And because of this rigid structure, adding that other piece of data is going to be really hard. And that aha moment in the analytics world, as someone who builds these things, is what I live for, is when I can create something that an analyst or a business person gets a new idea out of. I feel like that's the purpose of what I do. And the data warehouse kind of turns that, it kind of sours it, because you know that you might not be able to answer that aha moment for a long time due to the rigid structure of these systems. So there's a tension between the scope of what you're building and the desire to not miss anything. You have a tendency to put data into a warehouse that you don't even know that anybody uses, but they might need it because it's going to be so hard to change it in the future. Now, one of the responses to that in the analytics world was the advent of the data lake. And Mike, if you could advance the slide. The data lake is kind of a response to that. So this is newer. My customers really started building these in the kind of 2010s, early mid 2010s. This was a lot of Hadoop and MapReduce and Hive and stuff like that, on-prem systems. Nowadays, these are more commonly built on things like Amazon S3, where storage is super, super cheap. And that's one of the advantages of the data lake. Storage is so cheap, you can throw lots of data into it. And that has big implications for how they're used and how they're structured. It takes data as is in a semi-structured or unstructured format, and you can report directly off that data as is. So if you have third normal form data, you can import it in the data lake in third normal form and just report off of it like that. This is really kind of schema on write. You pull the data in as is, and you restructure it as needed based on your analytics use cases. You're not trying to guess up front, what does the data need to look at like? You only structure it when you know what people need out of it. The one thing though is people just tend to stuff data lakes full of whatever, right? They're just like, oh, we got some new data, throw it in the lake, throw it in the lake, throw it in the lake. And that's why I say, if the data warehouse is your analytics system of record, your data lake is your analytics record of systems. It tends to just be a reflection of all sorts of operational or cloud-based or sensors or log system that may exist out there, just packed with data in its raw format, untransformed. And then the idea is, well, we've got all the data here. Now anybody can go fishing in the lake. And all the data's here. It'd be easy to do self-service, all that sort of stuff. And the reality is, it's much easier to get data into a data lake, right? But you haven't solved the problem of having to structure the data. It still has to be structured at some point. And really, because the data lake has all this data in it, it's this record of your systems, you can answer any question. And that's really great. But the downside of that is sometimes when you can answer any question, it means you can answer no questions, because it's too hard to actually find the data that you need in the lake, or it's in a wacky structure that end users can't understand for self-service, right? This is why the terms like a data lake becomes a data swamp you'll sometimes hear. This is where that comes from. They're hard to catalog, they're hard to understand. You really have to put a lot of thought into structuring them the right way, or else end users aren't able to figure out what data they need, find the data they need, or make any sense of it. And self-service really requires actually a lot of work in a lake. And that's something that people discovered over the course of the 2010s. A lot of my clients spent a lot of money on data lakes, and then they never really got any significant use cases out of them, because they they did become data swamps. They're just packed with data that nobody can really find or understand. And the promise of self-service on the lake was never fully realized. And I've got just many customers who've done that. So one thing, if you went to Amazon's session earlier today, one technical response to this is what we call the Lakehouse. And I am a big fan of the Lakehouse. And this was another one of those ideas. When I first heard it, I was like, this is genius that someone came up with it. So what do we do? We got this system that's great for Bedrock BI and is great for because your analytics system of record. Then you got this other system that's really easy to get data into, fairly easy to transform it. Why don't we put them together in a logical flow from our source systems through different levels of the data lake, each level being more organized than the one before it, and then finally into an analytics engine. It could be Snowflake, Redshift, Incorda, right? A data warehouse, a system of record, something like that. This really allows us to do all of the things we mentioned before in one system. It logically organizes it. It gives us a place to point end users for different tasks. If you're doing planning or business intelligence, you go to the warehouse portion of the Lakehouse, right? But for data exploration or ad hoc queries, maybe you go to the cleaned zone. The cleaned zone is significantly structured. It may even look like a data warehouse, but it's not actually sitting in a data warehouse, a true data warehouse engine. But it's a great place for data exploration and ad hoc queries. Data science comes out of the curated zone. So it's a technical solution to all of the problems I outlined earlier. And it's very flexible. It's easy to get rolling on it. It scales wonderfully on the cloud. You can start small and grow as you need to grow. You only pay for what you use. All the things people say about the data lake is true, or the Lakehouse is true. And I wouldn't say, data mesh is not a paradigm that replaces the Lakehouse, but there are some nagging issues that the Lakehouse approach does not solve. It solves a lot of technical problems that we have as analytics practitioners and data engineers, but there's some fundamental challenges that remain unsolved by this approach. And so what are those? Well, first of all, it feels like we're stuck in this endless cycle of centralization and distribution, right? So where are you? You are in that cycle. Kind of depends on how recently the most multi-million-dollar data gaffe was, right? If it was in the last couple of years that someone made a multi-million-dollar mistake based on bad data, then you're in the centralization phase. You're pulling everything in. You're shutting down that pocket of Power BI and trying to get everything into Cognos, right? There's never enough data engineers to do the work. Even in the Lakehouse, even with a tool like, say, Trifacta that allows you to do a lot of self-service data pipeline stuff, there's still not enough data engineers to do the work. You produce shadow IT and rogue data engineers, people who are working outside the bounds of the Lakehouse. The Lakehouse does not solve that problem. It's a great technical solution to the problems I outlined earlier, but it doesn't solve the cultural problem like that. A big one is that there's a disconnect between the operational data owners and the IT data engineer. The people who know the data best and understand it are not the people structuring it for consumption. The Lakehouse is a technical solution to really pressing technical problems, and it's a beautiful solution for that. But there are remaining complex cultural and organizational challenges that a Lakehouse is not going to fix, right? So I think we need to change our perspective a little bit from being technology first to stepping back and thinking about our data as a product and thinking about the processes we go through to produce that product, and using a technology like a Lakehouse to help deliver that, but not counting on the technology to solve the fundamental cultural and organizational challenges that exist around building analytics. And so with that, I'm going to bring in Mike to talk through the data mesh concept, what it is, and why we're so excited by it.
Yeah, thanks, Ryan. That was awesome background. I think sets the stage well, particularly making that distinction between the technical solutions and the organizational solutions. And data mesh, it gets into both. I mean, it really does, but it starts from a place of saying, hey, are our organizations structured in a way that's optimal? It starts from a place of thinking about the people that are involved in data and analytics. That's one thing that's so exciting about it. So let's first try to start with essentially defining data mesh. I put on the screen here a fairly succinct definition, but it's a bit of a mouthful, so I'm not going to try to read it. I'm just going to let you kind of soak that in here for a minute while I give a little bit of background. As Ryan alluded to, this is very, very new. It was essentially invented a couple of years ago by a woman named Zhamak Dehghani. She published her first article on data mesh in May 2019. So that's why we're not experts. There's very few experts out there, but it's all just a learning process going on. As we've been saying, it really begins with this change in philosophy or culture or organizational structure, but it does progress kind of to prescribing some key functionality that should be present within a true data mesh. I think it's also helpful to know that this is not associated with any particular vendor. Now, I have seen some vendors that they've started to leverage this data mesh concept for marketing. Perhaps they're even starting to build in some functionality that supports data mesh into their applications. It's a little early to say, but there's no primary vendor that's kind of driving this conversation or anything. It's much more community based and kind of anchors back to Zhamak's writing. So it's easiest to understand, I think, by looking at the core principles behind it, which we're going to do in just a moment. But first, I want to look at the origination of the idea. So in order to talk about that origination, we really need to understand a distinction here between the two data planes. And I think this is going to be pretty self-evident as soon as we get into it for probably most of our audience on this call. So there's this operational plane and there's the analytical plane, right? So the operational plane is the data sources that underlie the business operational systems. So you have a point of sale terminal, customer buys a product, the transaction gets written back to a database, right? That's the operational plane. And then we have this analytical plane, and it serves up the data for all sorts of analytical purposes, enterprise reporting, business intelligence, data science. And these two are connected, right, by something called ETL, extract, transform, load, a data pipeline, whatever you want to call it. This data is pulled out of the operational systems, usually transformed in some way to clean it up, to aggregate it, and then it's loaded into some other type of data store for analytical purposes. Okay, so on the operational plane, there's something that's been applied called domain-driven design. Domain-driven design essentially means designing software in a manner that aligns as closely as possible to a business domain. So you're trying to make the software itself reflect the underlying business, as opposed to those things being completely separate. And a kind of well-known manifestation of this is microservices. Microservices provide sort of a window, if you will, a structured window into a part of the business through an API, through a structured API. And this has proven to be very, very successful. It's in use widely at this point. But the analytical plane, on the other hand, has continued to be monolithic for whatever reason. We don't have that same sort of domain-driven design thinking that's been applied there. Instead, data flows into a central repository rather than having these domains that specialize and host and serve the data in the way that microservices has done for the operational plane. So essentially, data mesh seeks to bring these domain-driven design concepts to the analytical plane. Okay, so here are the 4 principles of data mesh, and we're going to step through them in a bit more detail. The first is domain-oriented decentralized data ownership and architecture, data as a product, self-service data infrastructure as a platform, and federated computational governance. So let's start with domain-oriented decentralized data ownership. So that, again, is a bit of a mouthful. Let's define our terms a little bit. Most importantly, what is a domain? Essentially, a domain is kind of an area or a function or a slice of the business. The illustration that I have on the screen here is based on a music streaming service. This is what Zhamak Dehghani uses in her writing as an example. And so rather than try to reinvent the wheel, I took her illustration and included it here. Give some examples of domains. Now, there's nothing prescriptive for exactly what a domain is supposed to be, but she does provide some guidance in terms of how we might come up with domains, how those things align. And so obviously the domain should reflect the business, but a good place to start from a technology standpoint is with source systems. She calls source systems systems of reality because those systems basically take the data in a pure and unadulterated form and write them to a data store. So again, a customer purchases something through the point of sale terminal, that record gets written. That's exactly what happened. There's no transformation that takes place that maybe obscures the original meaning. But the reality is that's a good place to start. But in order to come up with a cohesive domain, we're probably going to need to pull together multiple source systems, multiple systems of reality in order to come up with a domain that can answer meaningful questions. So in the example here, you see artist might be a domain. There could be completely separate systems for onboarding the artist. That could be one system, and then a separate piece of software or system for paying the artist. Pulling in the data from both is going to be pretty key in order to create a cohesive overall domain. So once that domain is established, there's two types of data sets that generally are generated within those domains. One is a source domain data set, which just represents the data as closely as possible in its raw form. And then the second is a consumer-oriented or a consumer-aligned data set. The purpose of the second is to start to do some of that transformation that we're familiar with so that the data set can fit some particular access model, which really just means some particular customer need. But why is this important? Why do we really want to be domain-oriented? One of the primary reasons is so that we can scale. So there's this concept within architecture called an architectural quantum. And what it really means is a component of a system, the smallest component of a system that can fully function on its own. And in order to scale effectively, you basically have to identify these architectural quantums, and you want to have them be fairly succinct. So traditionally, in this monolithic approach to data and analytics, or the analytical plane of data, many roles and teams have to be involved in order to deploy anything new. So for instance, you have the network team, you have DBAs, you maybe have a DevOps engineer, you have a security analyst, you have an ETL developer. And these folks are not necessarily operating as a team. You potentially have a team for each one of those, and you have to coordinate all those areas in order to deliver anything new in terms of analytical data. So add a new data source, or even add a new use case potentially for that data, so to transform it in a different manner. So the proposal here is that instead of this kind of entire monolithic data pipeline being the architectural quantum, if you will, that smallest component that can function on its own, instead, we have a domain. And a domain is really made up of two roles. Doesn't mean it's two people necessarily, but there's two key roles. The first being the data product owner, and the second being the data engineer. So what do these roles do? The data product owner is responsible for the vision, for the roadmap for the data products. They're focused on customer satisfaction. They're focused on measures that improve data quality. They're defining success criteria, KPIs for their products. In order to do all this effectively, the domain data product owner really has to have a deep understanding of who the data users are, how they use the data, and then what native methods they're really comfortable with in consuming that data. So that can be very different. Think about a data analyst versus a data scientist. Just to kind of boil things down to a very basic understanding of it, a data analyst is likely going to be more comfortable with a SQL approach, whereas a data scientist might be a little more comfortable with a more programmatic approach, perhaps Python, for instance. So the data product owner needs to be thinking about those sorts of things to ensure that their data products are meeting their customers' needs. And then the data engineers, well, we already have data engineers today, right? So this role isn't entirely distinct from that, just because it's operating within a domain. But it is a little bit different because the recommendation from a data mesh perspective is that rather than just have that expertise in kind of ETL tooling, this data engineer should also have some knowledge of software engineering best practices, things like continuous delivery, automated testing. And this is, again, so we can kind of pull from the successes on the operational plane and bring some of those into the analytical plane. If someone has those general software engineering best practice knowledge, then they're likely going to be able to bring some of that knowledge into the analytical plane. Okay, so next, data as a product. So if we're going to treat data as a product, first of all, again, we need to define our terms. what are we really talking about when we talk about a product? So you might think of it as a thing you can buy, right? That's kind of what comes to my mind first when I think of a product. But conceptually, products are a sort of intersection between users, business, and technology. But maybe better defined, a product can be said to be a process between users and the business, and technology really acts as a bridge between the two. So then we need to employ what is called product thinking. And in order to do that, we need to understand these two spaces, we'll call them. So there's a problem space between the users and the product, and then there's a solution space between the product and the business. So the problem space is really what users need, and the solution space is what a business can give. What product thinking does is it connects those two things. It's the journey from the problem space of the users to the solution space of the business. That's the eloquent way to say it, but maybe to say it more succinctly, it's a singular focus on solving customer problems. And the goal is really to reduce that gap between users and the business. So this seems really simple, right? Kind of self-evident almost. But the reality is that this often is not how things are done. Not just within data, but within products in general. Often businesses start with solutions. So they say, hey, we built this piece of software. We think it's really cool. Hey, customer, what's your problem? Oh, yeah. Our software can do that, right? Or they think in features, say, oh, guess what? This is super cool. Our product can do this and this and this. You click this menu, watch what it can do. Isn't this great? Maybe it's great. It solves the customer problem. But often, it's more done from someone thinking in terms of technology or someone thinking in terms of something they heard once from a customer, came from a sales team. It's not necessarily focused on customer, user, market problems. So if we're going to have a product-centric focus, how do we bring that in terms of analytical data? Well, who are the customers? That's what we need to identify first. The customers are likely to be analysts, data scientists, and maybe even data engineers in certain contexts. So the domain owners, therefore, need to be tuned in to these users. They need to understand these users' problems before they deliver their solutions. And their aim should truly be to delight these customers, to provide them data products that fit their needs. So that's kind of conceptually data as a product, but data mesh actually goes a step further in terms of prescribing a sort of a set of capabilities that should be supported within data mesh. And these are outlined here. So we'll go through these fairly quickly, and then in a few minutes, we're going to talk about how maybe we can do some application of these principles. So first of all, should be discoverable. There should be some sort of centralized catalog where domain data products are registered so that they can be easily found. This is so that users don't have to go out and ask around for where they can find the data they're looking for, or explore 7 different systems to try to track it down. And so there's one central location where they can go and they can search, or they can browse and they can find the data that they need. Second, should be addressable. So there should be some sort of standard, unique address for each product. Now, this is really more of a programmatic term. So if you're thinking more in terms of kind of a data analyst, this might not be as meaningful. But if you plan on accessing data in a programmatic means, this becomes very important. Trustworthy and truthful. Obviously, data needs to be trustworthy and truthful, but there should actually be some accountability here. There should be some service level objectives for truthfulness. Truthfulness really means how closely it reflects the reality of the business events. Remember, we talked about the systems of reality. Those transformations can take place. They can obscure that. The data product owner should make sure that the analytical data continues to be truthful even as it's transformed. And going along with that data lineage helps that to be verified. You can see where the data came from and how it was transformed along the way. Self-describing semantics and syntax. So this just means that once the user locates the data, they can make sense of it. There's enough information there for them to understand how to use it. So this could include things like sample data sets or meaningful business schemas. Interoperability and governed by global standards. So this centralization doesn't go away completely, as we'll see more here in a couple minutes. There still are some standards that some sort of central body can provide that can provide framework. And so it's important that the data product is interoperable within those standards. As you might imagine, as you start to think about this concept, that's immediately one of the things that seems like a bit of a warning flag is, okay, so we have all these separate domains of data. Well, we frequently, for our reporting, for our analytics, we need to be able to bring those together. Absolutely. So a key focus in developing these data products must be that they are interoperable. Now, there's something called a global federated entity, which can help this interoperability take place. That's essentially, you might think of it as like a bridge table. So something like a master customer record that each domain can tie back into, and that global federated entity can be managed centrally, and the various domains can tie into it so the data can be joined together. And then finally, security. This may look a little different in the data mesh world, but really the aspects of security are going to be familiar. So things like single sign-on and role-based access control are going to be essential. The next principle is self-service data infrastructure as a platform. So this is really pretty simple. It's essentially saying that the domain should not be responsible for the infrastructure that's needed to deliver their data product. They should be insulated from that complexity. So the domain, the data product owner, the domain data engineer should not have to go out and figure out, hey, what sort of server do I need for this database, and what database platform should I be using? Now, they can have a say into what sort of data platform fits their data, but they shouldn't necessarily have to go out and figure out the technical details and consult the DBA to figure out all the specifics. So the idea is that there's a self-service mechanism through which a domain can say, hey, we want to spin up some data infrastructure. We want to provision some data infrastructure. Now, this is usually done through the cloud. You can have things like a Terraform or a CloudFormation script, and it can spin up some predefined set of data infrastructure. So the thought here is there's some sort of menu, perhaps, of available options that are provided centrally. Maybe there's a relational database option and an object storage option, a NoSQL option, and the domain can then choose the storage type that's most effective for their data, but they don't have to deal with all the details and the complexity behind it. So things that are likely to be included here are things like encryption for the data at rest and in motion, data product versioning, data product schema, and automation for things like data ingestion, registering with the product catalog, et cetera. And there never should be any domain-specific concepts or business logic that are part of the infrastructure as a platform. And so the idea here with what you see on the screen is that once that infrastructure is provisioned, the data product owner and the data engineer can jump right into the data product developer experience. They can get down to the business of creating the data product and tailoring it to their customers. And that data mesh supervision is just kind of that overarching foundation. The catalog is part of that. So some sort of place where users can go, they can find this information and locate it quickly and easily. The final principle is federated computational governance. This one I find to be kind of the most challenging to come up with the specifics in terms of how this might be implemented, but we're not really there quite yet. So let's just talk about a little bit about some of the concepts that are different in a data mesh governance world versus the pre-data mesh governance world, without trying to get too prescriptive about how this would be implemented. So in the pre-data mesh governance world, governance was very centralized, right? We had data governance committees, right? And this committee was kind of in charge of data quality, perhaps, for the entire organization. Well, you don't necessarily get rid of all central governance with data mesh, but there's a federation that takes place. Essentially, the ultimate responsibility shifts from the centralized body to the individual domains. So central governance can provide some sort of framework around things like quality and security, but the ultimate accountability for that shifts to the domain owner. Also, there's a shift from manual processes to automation. So in the pre-data mesh governance world, there's a lot of manual processes that go into ensuring data quality and security. The idea is that under a data mesh structure, a lot of that can be automated. And then finally, well-defined structures are often associated with governance before data mesh, right? Brian talked about the data warehouse. Structure is a key component of the data warehouse. So as your data is ingested, it must fit this well-defined structure in order to be accepted. Within data mesh, there's much more of an acknowledgement of the dynamic nature of data, how fluid it can be. And so it therefore empowers the domain owners to make decisions about the best structure for their data, the best structures that fit their customer needs. So finally, kind of returning to that idea that there's a philosophical or an organizational change that's needed in order to implement data mesh. There's some changes in language that I think are helpful. Anytime we want to enact cultural change within an organization, it's helpful often to change language. Those sort of small changes can be actually quite meaningful, I think. So here's some changes in language that are recommended. So rather than ingesting data into some central repository, right? Instead, the domains are serving data up to the customers. Instead of extracting and loading data from these various source systems, instead, users it's user focused here. See that in the language, it's customer focused. Customers can discover and use the data that they need. Rather than flowing data around via centralized pipelines, instead, events are published as streams. Users can subscribe to these events. They get the data that they need pushed to them. And rather than the centralized data platform, instead we have an ecosystem of data products that's being cultivated throughout the organization. Okay, so I think we are kind of tuned in now to the concepts behind data mesh. So now we want to talk a little bit about how do we actually do it? And here's where we kind of come back to what Ryan was saying at the beginning. We're not going to tell you here's how you implement data mesh, because A, we're not there yet, and B, probably your organization isn't there yet in terms of implementing pure data mesh. And that's no knock on your organization. We have amazing, awesome customers, and I'm sure your organization is doing some super cool things with data. But in exploring this, we think very few organizations are ready to just kind of step into immediately, we're going to implement pure data mesh. But you can start to enact some change, we think, in meaningful ways that are going to produce some results and are going to address some of those challenges that Brian talked about back at the beginning. Ryan, were you going to say something?
No, yeah, I was just, I mean, it's funny. It's really, that's the big question, right? Well, this sounds awesome. How do I do it? And as you can see, there's not a product you can buy that's going to do it. Anybody who tells you, yeah, our product, we built a data mesh product, like maybe someday, but like not today, right? There's no something off the shelf you're going to plug in to do data mesh. And a big reason behind that is, as you can see, it's a really significant cultural change for an organization. I mean, it probably requires a reorg to truly do data mesh from what you're doing today. And so that's a big part of what we want to talk about now, is just share our ideas about, okay, well, how do I start thinking this way? You know, because honestly, you know, there are a number of data mesh communities out there that Mike and I are plugged into, and there's such a raging debate now about what even counts as a data mesh that it's hard to point to a single organization who's actually doing it and confidently say, yes, this is a data mesh right here, you know, because someone will always have some objection of, well, but are you really doing federated computational governance? See, it's not a data mesh. And that's kind of what this part of the conversation is about.
Right. But I think that there's something that Zhamak says in her writing, where she says there's really a main shift here, which is treating the domain data product as the first class concern, and then the tooling and the pipeline as secondary, as an implementation detail, she says. And I think that really kind of sums it up well, why we can start to go ahead and apply some of these things. And she also points out that a lot of the current tooling out there, it does already support distribution and ownership by multiple teams. So that means we can go ahead and take some steps. And so, you know, a lot of our customers, probably some of you on this call, utilize Cognos analytics. That's a big part of our organizational expertise. And so we thought we'd talk about some of these things in terms of what you could do with Cognos analytics. Again, just to apply some of these concepts, not to imply that you can do data mesh with Cognos analytics. Also not to imply that you need Cognos analytics to be doing any of these things. Yeah. If you're using Power BI or using Tableau or using Encorta or any sort of platform, whether it be a BI platform or some other sort of data platform, a Trifacta, for instance, an Alteryx, you probably can take some of these concepts, because again, a lot of them are philosophical, they're organizational structure, and you can start to apply those things. So we just want to talk a little bit here in terms of how might you use something like Cognos to start to implement some of these concepts. And we actually want to kind of jump into Cognos and show you a little bit of kind of what we're thinking. So, sorry, let me actually step back here. So let's just kind of step through these real briefly, and then we'll talk about them and we'll jump into Cognos. So in terms of the first one, the domain orientation, this really is in many ways philosophical. I think out of all of these, this is maybe the one that kind of anchors most back to the philosophical. So if you empower domain owners to create things like data modules and data sets within Cognos, and if you're not a Cognos user, these are essentially kind of metadata models, and then a way to actually like manifest the metadata model to load it into a data set to create a sort of a materialized view, if you will. If you empower domain owners to create these sorts of things, and you connect them with their users, then they can actually start doing some of these sorts of things. They don't necessarily need to be as reliant on IT, because a lot of that functionality is there within the product, but it is probably going to require an organizational shift to allow them to do those sorts of things. And they can use, Cognos Analytics in itself can be sort of an underlying data infrastructure, if you will. There's obviously infrastructure underneath the Cognos Analytics, but if we go back to kind of the cloud deployment model, you can set up a system like a Cognos Analytics to auto scale. So as a domain, for instance, they bring on a new customer-centric data set, and new customers start using the system, the app infrastructure in the back end, it expands to service those customers. There's nothing needed. The domain owner doesn't have to say, oh, I need another server because I'm going to have 15 more users. No, the system just auto scales to serve those customer needs. So I think that's a sort of principle that underlies this that can serve that sort of domain-oriented decentralization. The self-service data infrastructure is a platform. I kind of was just speaking to that. Again, the whole idea is that once you have it spun up, maybe you set up that auto scaling, or you have some cloud formation templates that spin up your underlying database, or you just launch an RDS instance, which can be a relational database that you can essentially spin up by answering a few questions through your AWS portal or through some sort of application you create. You can then immediately drop that domain product owner and the data engineer into the developer experience. And the developer experience is things like data modules, again, where they can start creating those metadata models. So even jump into creating some sort of analysis and a dashboard or a report. And then you have that portal that's allowing a user to find the data that they need to easily search both names of models and also what's inside them to locate the data product that they need to answer their questions. Now, the federated computational governance, as I alluded to, we're not even going to try to get into that today. We're not going to try to tell you a way you can do federated computational governance or even apply those principles really through Cognos, other than, yes, there's some sort of central portal that can maybe tie things together. But there's a lot there in terms of kind of automation and automated kind of data standards and such that probably cannot do, first of all. We certainly haven't figured out a way to do them yet. So there's a lot more conversation to happen around that one. But the one that we kind of wanted to focus on here and actually like look at a little bit was data as a product. And so Ryan, do you want to take over here and kind of share a little bit about just some things that maybe we can take some of these concepts and apply them within Cognos?
Yeah, absolutely. Let me get my screen open here. Okay, so should be able to, yep, you can see my screen. Great. Okay, so again, the disclaimer here. Cognos is not a data mesh product. I know Mike said it. I'm just going to say it again because I don't want anybody coming at us saying you guys said Cognos is a data mesh product. We did not say that. But the principles I think you can use today in a platform like Cognos or in another analytics platform to start moving towards a data mesh way of doing things. And one thing you'll notice as I'm showing you this, we're using a BI tool. We're talking about BI tools. When you read the data mesh literature, it's much more couched in a much more developer-focused language. We're talking about APIs. We're talking about people who are writing code. And they do acknowledge that like the common interface won't just be APIs in a data mesh. It will also be SQL. So keep that in mind as we're going through this. But so some of the things we wanted to talk about. So I have a Cognos Analytics instance open here, and I just wanted to talk through data as a product a little bit for you briefly before we wrap up, and how you can do this today. The first thing to think about, this manage menu, okay? This is a suite of capabilities that are typically, kept in, like the priests in the temple are allowed to open this menu and no one else. When we move to data as a product in a domain-oriented architecture, we're going to take most of these capabilities and distribute them outside of the central BI infrastructure team. Now, the admin console, yeah, we're probably not going to give every domain owner access to that, but everything else you see here is appropriate for a domain owner to have access to, especially the ability to configure new data server connections. So a domain owner in this world goes on to goes into your automated way to spin up infrastructure. They spin up a new MongoDB database on AWS, and now it's time to add it to Cognos. They need the power to do that without calling you. Or even better, if you can automate that with, say, a CloudFormation template or something, that's even like next level. And it's doable, but at the very bare minimum, you need to give people the ability to do these things on their own. The domain owner must be able to own the domain. Okay. Now, when it comes to a data product, what is a data product and who's responsible for producing it and that sort of thing? In the context of Cognos, I just created some simple examples that I wanted to show you here of domains that might exist and how you might handle them in the context of Cognos Analytics. So I created 3 domains: customer management, order fulfillment, and sales. And these, you're not going to believe it. I have an example that is a fictional sporting goods company that was in business in the early mid-2000s, a Go Sales data warehouse. And what I've done is I've gone ahead and I've created some objects to show you what the domain owner and the domain engineers might produce within Cognos that help build the data mesh-like structure within Cognos Analytics. So if I look into this sales folder, I have analytics content and I have data assets. And within the data assets, I have a sales module that has been produced within the sales domain by the sales domain product team, not by the BI team, not by the central engineering team. Those people are in charge of education, provision, and assisting with development. They're not the bedrock of who's building content within this paradigm, okay? And if you look at this, I'll pop it open just so we can eyeball it real quick. You can see, I mean, we're all familiar. If you're familiar with Cognos, we're familiar with this data set because it's probably a data set we all learned on. And what's in here? And it's a slice of data that I've created. It's in this sales module. Now, what I make available here is I've also created a data set. And that data set kind of, you can think of as it's a small example of a data product that I might make available within my domain to both my end users and to other domains in the data mesh, okay? And so the form this takes is that there's a team of people who are in charge of maintaining the stuff that exists in this sales domain. We are providing them with infrastructure and guidance. They understand what objects they're supposed to create. We've given them the basic rules for what it has to look like. Like, you are going to create individual data sets, and those individual data sets will be available on the mesh for people to access. You can use it within your domain, but people can connect to it from other domains. You can federate between domains via the data sets, okay? We provide the guidelines for them and what needs to be built, but they do the building and the maintenance. And then what ends up happening, you can see I've got my data set here in sales. I look at a different domain. I've got this order fulfillment domain, for example, same thing. Now, obviously, this is a simple example. You might have a lot more data products available here, but these are just simple examples that we can use. And then these are 2 separate teams. They're responsible for building the products that delight. They're the kind of the operational and the analytics team combined in one, right? They understand the operational data. They build the analytics on top of it. The 2 planes that Mike was talking about earlier of the operational analytics plane kind of come together in this product team. The way we federate between these within the context of something like Cognos is, you can see I've created a domain catalog. And the domain catalog here contains the order data set and the sales data set, okay? And what happens if I want to, say, federate these together? And this is a simple example, but let's imagine I am, I want to federate these together. I'm a self-service user. I want to take data from these two domains and I want to add in a spreadsheet or something for something I'm doing, okay? How do I do that? Well, here's what I do. I'm that end user and I'm going to go new data module. I am going to navigate to the domain catalog. I have now inherited the data products from the order and sales domains and into this data module, okay? I can now join them together. I can join the domains together on common elements. If there is no common element, one thing Zhamak advocates doing is kind of creating, canonical data sets that you can use for the purpose of joining domains. Mike, do you remember the exact term she uses for that? It's escaping my mind.
Federated entities?
Something like that. There's a lot of new language you're going to learn when you're reading this book, but it's mind-blowing. If you're a geek on this stuff like I am, this is mind-blowing concept, right? So the beauty of this is that those domain teams, those product teams can make updates to these data products, and it will automatically flow through now into the model I'm building. So we've set up a structure now where I have an order domain and a sales domain. They are each separate. They are running and doing the things they need to do for their domain, independent of one another. And this is why I love this concept, because in a traditional data warehouse world, everybody moves at the pace of the slowest mover. And here, if the sales team is really crushing it and just producing all sorts of amazing data products, and the order team, for whatever reason, is not, the sales team is not hindered by that. And when it comes time to integrate the domains together, I can do it within Cognos in a way that allows me to combine the data products in a robust way. Because this data module, when I save it, because these are linked modules, when a change is made, say here in the sales domain, it is going to automatically appear in this domain, in this model I've created that joins the two domains together. And this is what allows us to kind of push responsibility out to the data product owners, enable them to do what they need to do to run at their pace to create the data products that they need. And yet we maintain the ability to federate and govern within the context of a BI tool. Now, this is not, if we look at kind of the data as a product capabilities, what have we covered here, right? Well, discoverability, we have this search available in Cognos. It's easy to discover things. And we have a natural language query engine that can search across the domains based on the things that people have typed in, right? Is it addressable? Well, in a classic sense of talking to APIs, I don't know that I would call this addressable, but it is addressable insofar as the collection of independent data sets following the standards and available in Cognos via search are easy to find and understand. Is it trustworthy and truthful? Well, it should be. We've put the guidance in place that the domains need to use, and then they're free to run within those guidelines. So this is an example. Also, security is an important part of data as a product. We all know Cognos has a very robust security model built into it. So again, I will throw that caveat one last time. Not a data mesh. I did not just build a data mesh. But what I did is I took data mesh concepts and I applied it to a tool that a lot of you watching right now likely use, and describe to you how you can start to data meshify a little corner of what you do. A full data mesh implementation is going to go well beyond the scope of a BI tool. In fact, it's not about the tools. It's not about the tools at all. And I hope Mike and I have made that clear. Any thoughts on that, Mike?
No, I think we're about out of time. Otherwise, I'd be tempted to hop in some more. So I think we maybe have a minute or two left for questions. Yeah. So we better jump over there. Sorry, I think I talked too long.
No, I mean, it's, the thing about it is we're both so excited. Yeah, it's just too cool. And so let's take a look at some of the questions that we had roll in.
Kevin, you gonna throw some questions our way?
Yeah, so let me take a look at a couple of these. Like you said, we don't have a whole lot of time, but we'll try to get through a couple of these questions here.
Rapid fire them.
Yep. So let's see here. are there any specific tools that do data mesh? I think
No.
we covered that pretty well. Okay.
And anyone who tells you their tool does data mesh is not being true. Now, if you look at the data mesh book, you will see it's sponsored by Starburst. And Starburst is a very interesting tool that I think fits nicely into a data mesh, but it is not a data mesh tool.
Okay, great. I'll fire off a couple more here. What are some good resources for learning more about data mesh?
Oh yeah, actually, a slide for that. Sorry, I forgot to share it. Sorry, ask the next questions for out of time. I'll put that up, some resources.
Okay. There's more of a general question. What are some of the limitations of data mesh?
Well, I think in my mind, the biggest limitation of it right now is honestly, it's so amorphous. It's hard to even answer that question, right? Like, what is it going to be bad at? It's hard for me to tell you. I can tell you very easily the failings of the data warehouse. There are a lot of great aspects of a data warehouse, but the failings are clear. What are the failings of data mesh? It's hard to say right now. Mike, I don't know if you have any thoughts about what those might be.
No, I was going to say just that it's not fully fleshed out and defined yet. Like you said, the book is still being written. There's no handbook to go to when you run into a real world problem that hasn't really been addressed within the current writings on it, or maybe even when the first edition of the book comes out. So I think that's what I would currently identify as the limitation, is kind of the unknowns, the real world solutions that still need to be worked out.
Yeah. I mean, I would say here's where we are with this. Like, think about when this book came out, the Data Warehouse Toolkit. Now think about Redshift or Snowflake, right? We're in the data mesh world of pre-publication for of this. So this is going to be a journey.